Good morning to everyone. Today in this video, we will discuss about organic chemistry, some basic principles and nomenclature of organic chemistry. As we know that carbon has a unique property called catenation, due to which it forms only covalent bonds. Carbons share their 4 electrons from their outermost orbit. As we know that carbon having atomic number is equals to 6 and their electronic distribution in different cell is 2, 4 and therefore it is also known as tetravalent. Okay, when we discuss about the shape of organic compounds, we have shapes like tetrahedral, planar structure, linear molecular structure in the different 3 types of hybridization, like sp3 in alkane single bond, sp2 in sp3 in alkane single bond, sp2 in alkene double bond, sp in alkyne triple bond. Expand each of the following condensed formulas into their complete structural formula. We have very first question CH3, CH2, CO, CH2, CH3, in which we have 5 carbon atom and we just have their long chain structure providing them hydrogen from each side, satisfying the valency of carbon. Now again we have bond line formula. Okay, so we have a question in which HO, CH2, 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 CH, CH3, CH, CH3, CH, we have to write in the condensed form. See, we have 3 CH2, 1, 2, 3. So, we have represented CH2 whole 3. Again, we have 2 CH2 simultaneously. Then we have represented CH3 whole twice. Now, the bond line formula, each vertex represented a carbon. Okay, and we have one hydrogen sharing in this side and one hydrogen in this side. And here, hydrogen and hydrogen, which represent CH2. Okay, in the corner we have single carbon having only one share of their vertex, so we have 3 more space available for carbon which occupied by hydrogen and which makes CH3. And next we have to expand the following bond line formula to show all the atoms including carbon and hydrogen. See, as we have a structure like this, I have already explained each vertex represented by carbon. This carbon having already shared their 2 electron, so it has only similarly H2, CH2, CH2, CH2. Done. Now what we have more option like this. At this point, carbon already shared 3 electron, so we have only one space available, so we give CH. At this point, we have already shared 1, 2, 3. So 4th hydrogen CH again. At the corner, this corner hydrogen having shared only 1 electron, so we have H3 this side or H3 this side. So I hope you understand the bond line formula, representation of bond line formula. Now we have a classification of organic compound. Organic compound classified in 2 different types: acyclic or open chain hydrocarbon and cyclic or closed or ring compound. We have example like CH3, butane, hexane, propane. These are the example of open chain compound known as acyclic. And cyclic, in which it makes a closed chain like a benzene C6H6. Now cyclic again classified into 2 types: alicyclic and aromatic compounds. So we have 2 more classification of alicyclic: homocyclic or carbocyclic and heterocyclic. Aromatic compounds classified again in 3 different types: benzoid, non-benzoid or heterocyclic aromatic compounds. Okay. Functional group: hydroxyl group, aldehyde group, carboxylic acid. These are the functional group. And homologous Cs, we have homologous Cs, same family member like alkane, single bonded family, double bonded family, alkene, triple bonded family, alkynes. Haloalkanes are there. Alkenols are there, alcoholic acids are there, amines are there. Okay, so these are the homologous Cs. Now, as we know that the full form of Iupac is International Union of Pure and Applied Chemistry, and this organization is responsible for the designing the symbols and the formula of the chemical, organic or any chemical element or symbol. Okay, so basic nomenclature we have already studied in class 10, that the single bond represented by ANE, double bond represented by ENE, and triple bond represented by YNE as a suffix. And we have a prefix from carbon 1 to carbon 10, which is meth, eth, prop, but, pent, hex, hep, oct, nan, dec. And we have also C carbon 20 and C carbon 30. So these are the prefixes. Okay, let's move to the other part of the chapter. And very important, this name of the alkyl groups. So when we add methyl, ethyl, propyl, butyl or decyl in while writing the IUPAC name, so when we have a CH3 branch in the long state structure of the hydrocarbon, so we add methyl. When we have CH2, CH3, then we'll add ethyl, CH2, CH2, CH3 propyl, CH2, 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 CH3 butyl, and CH2, CH2 old trice, and CH3 decyl. So when we use it, I will explain you later. So this table is very important. Now let's understand the root of nomenclature of branch chain alkene. The longest carbon chain in the molecule is identified. First of all, you have to identify the longest carbon chain, and then after numbering done in such a way that the branch carbon atom gets the lowest possible number. So when we have option of numbering branch 1, 2, 3, 4, and we have another way of writing 1, 2, 3, 4. Okay. So the name of alkyl group is attached to the branches and prefix in the name of the parent alkane, and position of the substitution is indicated by the appropriate numbers, like positioning 1. If a group having the position 1, then we can put there 1, and then after we can write butane and like this. And they are listed in appropriate alphabetical order. So be very clear that by writing IUPAC number, alphabetical order is very must. So, and thus the name for the compound shown as below. Okay, let's move to the more example. See, In the two or more identical substituted groups and present in the numbers are separated by the comma, they are separated by the comma, and the names of the identified prefixes such as di for 2, tri for 3, and tetra for 4, penta for 5, like this, and writing the name of the substituent in the alphabetical order, and these prefixes, however, are not considered. So these tri, di are not considered as distributing the alphabetical order. Only their name are identified as the alphabetical order. Okay, so we have a very first nomenclature: CS3, CS3, CS2, CS2. Okay, so we have first write their ordering 1, 2, 3, 4, 5, and in which we have methyl CS3 and CS3 at 2 and 4. So what we do? We do 2, 4 dash 2 methyl. So we can do dimethyl, and then after 1, 2, 3, 4, 5. We have 5 carbon atom in a main chain. So pent, all are single bonded. So pentane. Okay. Next we have CS3, CS2, CSC, CS2, CS2, CS3. Okay. So we have at the 3 we have CH2, CH3. So which is known as ethyl. So what we do? E, and we have methyl at 4 number branch. So M. So E comes first in the alphabetical order and M comes later. So therefore we start with ethyl. So at the third position we have ethyl. So 3 ethyl, 4 dimethyl, and we have 7 carbon atom, therefore heptane. Okay. So this way we do nomenclature. Now let's come to the cyclic compound, and the prefix of cyclic compound is cyclo. So see, we have cyclo means it is a closed cyclic compound, and we have C 1, 2, 3, 4, 5. So therefore pentane. Done. Now in this question we have 1, 2, 3. We have danced already by the getting the number 1, 2, 3. At this position we have CS3, at this position we have CS3. So what we have at 1 number we have dimethyl, and 1, 1, because at 1 only we have 2 methyls are there, and at 3 we have CS2, CS3. So we have at 3 number we have ethyl. Again M comes later, E comes first. So 3 methyl, 1, 1 dimethyl, and then after what? Cyclo. Cyclo we use for the cyclic compounds, and then we have 6 carbon atoms are there. So hexane. Okay. So this way we have to do. Okay. Next one is propyl. How it get propyl? Benzene. So this is the structure of benzene, C6S6, and here is CH2, CS2, CS3. So CS2, CS2, CS3, propyl, and then after benzene. This propyl, methyl, ethyl, you need to learn from this table: methyl, ethyl, propyl, butyl, and decyl when we use according to a structural formula as a branch. Let's move to the another part of the organic compound in having the functional group. Okay, so then we have a functional group like this. Very first question we have numbered 1 to 8, in which as we see at number 3 we have alcohol, we use suffix OL, and we have at number 6 methyl CS3, and there are total carbon atom 8. So octanes are there. So we have, as we know that there is the suffix of alcohol OL at 3. So we done octane. So octane E removed, and 3 we get the position of 3 and put the OL. And at number 6 we have CS3 known as methyl. So 6 methyl octane 3 all. Okay. So this is the IUPAC name of the structure. Move to the next question. We have at number 4 and at number 2 we have ketone, and the suffix of ONE, one. Okay. So we have 6 carbon atom. So hex. And why we use this? Let's try to understand why we have done here M methyl first and octane O later, because M comes first in the alphabetical order, O comes later. And here in the case of di we are not considering this tri, we consider O, and O and H. When we compare O and H comes first. Therefore here we write hexane first, and then after 2, 4 dione. 2 times ketones are there, so we use dione. Okay. Next, this is very important one. When we have already suffix are there, then we use prefix of ketone. The prefix of ketone is oxo. Prefix of ketone is oxo. So oxo, then after hexanes are there because 6 carbon atom is there, so hexane, and then at number 1 we have carboxylic acid, so we use oic acid. So oxo hexanoic acid. Okay, and this ketone is branched at 5 numbers, so we have given there numbering. Then after we have hexa for 6 carbon atom, 1, 3 diene for the triple carbon atom. Now we have a substituted benzene compound. See, methyl is added over there, and benzene C6S6. So methyl benzene. After that methoxy benzene. NO2 nitro benzene. Bromo, they are the halogen groups are there. 1, 3 dibromo benzene. Okay, easy one. See, we have at position 1 we have chloro, so 1 dash chloro. 2, 4 we have dinitro benzene. Okay, similarly we have 2 chloro, 1 methyl, 4 nitrobenzene. 2 chloro because C comes first, M comes later, and after that N comes in ABCD. So we have used 2 as 2 chloro, 1 methyl, and 4 nitrobenzene. Similarly the last one 3, 4 dimethyl phenol. So this lecture has been completed. I hope you understand all the rules of writing IUPAC nomenclature of organic compound and understand the classification of organic compound. Thank you very much.